Hello, today we're going to talk about Quicksort. So Quicksort is a really fun sorting algorithm. It uses a divide and conquer, how do you spell conquer technique. What does that mean? It means that we're going to take a problem and break it down into smaller subproblems because they're going to be easier to tackle. So basically we're going to have a list of elements, and we're going to take an element from the list and place it at a position that we call a pivot. So we're going to take an element and place it at a pivot point. What is this pivot point? Well, the pivot point is special because everything to the left of the pivot, is going to be less than or equal to the pivot. Everything to the left of the pivot is going to be less than or equal to the pivot. To the pivot, and everything to the right, what do you think it's going to be? Everything to the right, the right of the pivot is going to be greater than or equal to the pivot. Okay. Everything to the right is greater than or equal to the pivot. So, how does this help us? Basically, we're going to take a list and we're going to have these pivot points throughout the list, which are going to be sorted. And then we're going to break our list into sublists, and we repeat the process. So we recursively repeat quicksort on the left and right sublists. So repeat quicksort on the left and right list until we get, running out of, just got a little bit of room left, we get size 1 sublist. At that point, we'll have a completely sorted set of sublists. So let's try and take an example with some numbers and kind of step through it and see how everything works. Okay, we're going to try and step through this example here. So I've got an array of numbers and we're going to go through and find our pivot. So we're going to use 50 as our first pivot. We can see that we have 4 elements that are less than or equal to 50. That would be 45, 20, 43, and 10. So we're going to need to take care of the 60. The 60 is going to have to get moved with the 10, right? We're going to have to move that with the 10. And then we're going to have to move the 74 with 53. And then 50 is going to come over here where 74 is. Then everything to the left of 50 will be less than or equal to 50. And everything greater than or equal to 50 will be to the right of 50. Let's go ahead and do that. So we're going to get 43 here, and 50 is going to go here, and then we're going to get 10 here. 6 is going to go where 10 was, so we're going to have 74, and then where 10 was, we're going to have 60 now. And then we just got to fill in the blanks. 45, 20, 83, 68, 85, 89, and 71. Okay, important thing here is I've written to the left the criteria for finding the pivot and splitting this thing up into two sublists. So we're going to need these indices. That's why I always focus in these videos on the indices. It's super important to focus on the indices. So 50 is at position 4. So that means our pivot is at position 4. Now for our left sublist, our lowest bound is going to be our new low bound for our left sublist. So that would be 0. And then our upper bound is going to be p minus 1. So what is p? What is p? P is 4. What is 4 minus 1? Well, that's going to be 3. Okay, and then for our right sublist, our lowest bound is going to be p plus 1. So what's 4 plus 1? P. We'll call this left, and this is left, and this is right. P right is going to be equal to 5. And what's our upper bound? It's going to be our upper bound from before. So up right equals 11. And so we're going to repeat this process for the left side and the right side until what? What was our base case? What did we say? It's when we have a size 1 sublist. So when we have just one element left, then we're going to break our recursion of doing this process over and over and over and over again. So let's start by going through this left side. So if we go through the left side, 43 is going to be our new pivot. That's our starting point. And there's two elements that are less than 43 and one element that's greater than 43. So the two elements are going to go to the left. So we're going to get 20 and 10. And then 43 is going to, I want to keep my spacing the same. So 20 and 10. 43 is going to go here, and 45 is going to go where 10 used to be. And then we're going to have 50. I'm going to make a box around 50 because 50 is in its spot. This is done. And then we're going to have 80, 83, 74, 68, 85, 60, 89, 71. Now we've moved 43 into the correct spot. So correct, we have our pivot here, and then we're going to repeat quicksort to the left and to the right. Well, if we do it to the left, we're going to get 10 here, and then 20 is going to go here. This is boxed in now. We already did 43. We have 45, 50, 83, 74, 68, 85, 60, 89, 71. Okay, now we need to repeat quicksort on the left sublist. Well, guess what? That's our base case. We have a size 1. Done. So we don't even need to do any more recursion. Oh, let's go over to the right side of this. Let's go over to the right side of our pivot 43. If we do the right side of 43, we're going to get that this is a size 1. So we break the recursion again. 45 is boxed in. So we just did the left side recursively. And then we repeat the same process for the right side. We go all the way through the right side. Well, we're going to end up with 83 as our pivot for the right side, right? If we do this one, we're going to get 83 as our pivot. That's our lowest bound. So we're going to have 4 elements that are less than or equal to 83. That's going to be 60, 74, 68, 71. So we're going to get 60 here, so we're going to have to swap 60 and 83. 83 is our pivot, so that's fine. That's going to go there. And then 74, and then 68, and then 71 needs to go here, so we're going to swap 71 and we need 85 and 89. Okay, so now we've done the right sublist. Remember, all this stuff over here, we're done with this 43, 45. So you repeat this process recursively again until you get to the base case where we just have size 1 left over. Not going to go through the whole thing because I'm just going to run out of paper. But yeah, that's all we have to do is just keep on repeating this process until we only have one element left. All right, let's look at how we can implement Quicksort in C. Before we go on to actually look at how we implement this in C, I just want to kind of go over how to do a partition, because that's also really important. So if we go back to the example that we had, it was 50, 45, 20, 60, 74, 83, 43, 68, 85, 10, 89. Sorry, this recorder thing's in the way. 89 and 71. And if you're like wondering how to follow this video, I really would recommend that you just kind of copy what I'm doing on paper and step through the algorithm step by step like this. Okay, so how was I getting 50 into the right position? Well, I set my lowest bound is equal to 0, and then I need to have some way of counting the elements that come after 50 and finding the right spot for 50. So I'd set a new counter equal to 1, which is really the lower bound plus 1. So that's I is equal to the lower bound plus 1 first. And then we need to find the upper bound, right? So what do you think it's going to be? It's going to be up. So J starts out at upper. So we have our lower bound and our upper bound, and we need to first go through and find out, where, like, what things are greater than or equal to 50. So if we let our array index AI, we're going to check everything against our pivot. So we're going to set pivot equal to A low. So this is our pivot right here, 50. 50 is our pivot, right? That's the thing that we're checking. So we want to go through this list and check to see if we have any elements that are less than our pivot or greater than our pivot. So we're going to be checking condition well, I is less than or equal to j, number 1, to go through the entire list. And then we're going to check while AI, starting from the lower bound, is less than pivot, less than or equal to pivot, and I is less than our upper bound to make sure that we don't go, over out of bounds of the array. We're going to do I plus plus and then we're going to do well a j coming from the right greater than or equal to pivot, and well, j, we don't need to actually check anything on the array. So because we're gonna, this is our pivot point right here, right? So we're gonna break that if we keep on going through decrementing j. So that's exactly what we need to do. We need to decrement j. So we're going from this direction. We're going to run into the pivot, and that's going to break this while loop. So if either one of these while loops break, we're going to want to swap. Elements. So if I is less than or equal to j, we're going to swap, and then we're going to increment I plus plus and j plus plus. What that's going to do is it's going to allow us to go through and put 50 in the right spot. So this would put 50 in let's put 50 in spot 74 and swap all the elements just like we saw in the first example. Okay, now we're going to look at how we can implement this in C. Alright, so let's go ahead and close the stuff from yesterday. And we're going to make a new folder here. We'll call it Quicksort. And like always, we'll add two files. We'll call it quicksort.c. And I always add this header file just because like later on I usually put my functions and libraries and stuff in that header file. Okay, quicksort.h. Alright, so first we're going to include standard input and output, stdio.h. I think that's all we're really going to need. And then I always come back and do this, so why don't we just do this right now? Let's define the size. Let's use an enumerated type to define the size of the array that we're going to use, because we're going to use an array. So define max 100, and we're going to make our main function return 0. Typically at this point I would compile it and test it, but we're just going to get straight into programming it. So we know we're going to need a function for quicksort. So we need quicksort. And quicksort is going to take in the array that we're trying to sort, and then it needs to take in a lower bound and an upper bound. And then we're also going to need that partitioning function that we just talked about. So partition int A, int low, int up. This is going to help us get our array set up so that our pivot is in the correct position. And a lot of this code that we need to test this is going to come from the stuff that we've already written before. So why don't we look at the one that we did yesterday. Let's get a merge sort. So go merge, and yeah, we always use this same exact thing. So we always set a size of the array that we always set the array. We initialize the array. We get a block of memory for the array, and then we set how many elements we're going to actually enter. Then we ask the user to tell us how many elements they want to enter, and then we fill in the array with the data that they want to enter, and then we show them the array that they have, and then we run our algorithm, and then we print out the array again. So it's the same routine that we do every time. This is just a really good way of testing that everything works. So let's go ahead and grab all of this code down to here. I'm actually going to grab all this code just down here. So what this is going to do is you're going to show the array to the user and get the user input. All right, so paste that. So back to merge. And the last thing we want to do is show them the array once we've sorted it. So this is before sorting. This is after sorting. Okay. And this is going to be really similar to merge sort because we're going to use recursion. So here we're going to run quicksort. So we have our lower bound starts at 0 and our upper bound starts at n-1. So this is going to go into 0, and then this one's going to go into up. So this is our lower bound. This is going to be our upper bound. Now we actually need to go through and implement Quicksort. Let's go ahead and make our implementation down here. Quicksort. Let's just get this code from up here. All right, paste it, and now let's get started. So we're going to use our pivot int p, and the base case that we need to check is if we have a size 1 subarray. So when would that happen? If low is greater than or equal to the upper bound. At that point we know that we have just one element in the sublist we're going to return. Now before we do our recursion, we need to partition and find the correct position for the pivot. So p equals partition a, pass in a lower bound and the upper bound. Gosh, if I can get that right. So that's like just like in our example when we had to move 50 into 74 spot and get everything to the left less than or equal to 50 and everything to the right greater than or equal to 50. And then we're going to run Quicksort recursively on the left sublist and on the right sublist, right? So for the left sublist, we're going to have a low, and then that's going to go up to the element just before the partition, so p minus 1, so that's our upper bound. So this is going to be for the left sublist. And then we're going to run Quicksort on the right sublist. So you could literally just copy this thing right here. What do we need to change though? We're not going to start at low, we're going to start at the next element adjacent to the pivot. So what would that be? That's going to be the pivot, and then we got to go over 1 to the right, so p plus 1. And our lower bound, yeah, so we just did our lower bound. Our lower bound is p plus 1, and our upper bound is going to be up, not p minus 1. We got to go all the way to the end of the sublist, and this is going to be for the right sublist. All right, and now the next thing we need to do is our partition. Okay, so let's go ahead and declare our definition, our implementation down here. So void partition. Wait, nope, int. Well, I put down the wrong thing. Int partition. We need to return the pivot array. Partition. I'm just going to copy this from up here. So I have typing all that out. Okay. All right. So we need to partition our array into the right. We have to find the right partition. We have to find the right position for our pivot. So we have to start with our int I equals to low plus 1, just like we saw in the video, and then our int j equal to up, and our int pivot is going to be equal to a low. All right, and all we need to do is check that while I is less than or equal to j. So this is the lower and upper bounds of our list that doesn't include our pivot. And then while AI is less than or equal to the pivot, this is where we're going to put in those 2 while loops that we're checking, and if they break, we're going to swap our elements. And I is less than or equal to up. We're going to increment. So what does this do? This will move us from left to right in our less than or equal to pivot. Maybe I'm doing something wrong here. Less than or equal to pivot. No. And oh yeah, I forgot. Okay, so in C, we're checking two Boolean conditions, so we need to put parentheses around each one so that they execute. Okay. And, well, oh, didn't put that. It was a Visual Studio Code thing. I think that should take care of it. Well, int I. Okay. Let me pause here for a second and see what's going on. I'm not sure why that's an error. Well, I don't know. Somehow, you know, when you're talking and typing at the same time, you kind of mess up and you forget where you are. Well, I got parentheses around AI. So, yep, that took care of it. So I had an extra parentheses. All right, so this is going to move us from left to right in our list, and we need to also check going from right to left. Well, a J going from right, the rightmost bound, to the leftmost bound, so we know we're going to go a J greater than the pivot. We don't need any brackets for that. What the heck? Okay. And since we're starting at the upper bound, we need to go to the left, so we're going to decrement J. All kinds of typos. Okay. So if either one of these breaks, then we want to check a condition. If I is less than or equal to J, we're going to swap our elements. So we're going to need another variable. We'll call it temp. So int temp. And if I is less than or equal to J, we're going to swap our elements. So AI, we'll store that in temp. And then AI equal to a J, whoops. And then a J equals temp. And then we want to increment I from the left to the right and decrement J from the right to the left. Okay. Otherwise, we found a proper place for the pivot. For the pivot break. Okay. All we need to do is just assign our pivot here. So while, okay, this comes out of here, and then out of the while loop we have a low equals a J, and we're going to have a J equal to our pivot, so a J equal to pivot. So that's gonna that's like kind of swapping that's putting the pivot in the right spot there. And then we're going to return our Jth position. We're going to return the place of the pivot. Okay, so this should take care of our partitioning. That was kind of a long one. Now I'm sure, because we wrote all that code, we probably have something broken, so let's try and run it. So cd into Quicksort ls, and we're going to type g++ to compile our C file. So quicksort.c -output proc, so we're going to compile that into proc, and let's run that. Hey, no errors. So let's try and do the example from the video that we watched. I still have it written down right here. So we got 11 elements we want to add to the array. Shoot, no, not 11. We have 12. Arrays start from 0. We have 12. Okay, so the first element is going to be 50. Next element's going to be 45. One after that is going to be 20, 60, 74, 83, 43, 68, 85, 10, 89, 71. Wow, all right, that all went very smoothly actually. So here's our unsorted array, and here's our sorted array using Quicksort. Well, if you like this video, I typically try to put out as many videos as I can in C programming, mainly things related to algorithms and data structures. So if you like this video, like or subscribe and leave me a comment. Have a great day.